Hello everyone. So today I want to talk about the rational roots test. And before we start talking about it, I want to talk about what is the point of rational roots test? Like, why do we need it? So over here you can see a polynomial and it's x to the fifth, right? With the leading coefficient of x to the fifth. And I want to find the roots. Well, the thing is, I don't have a formula like quadratic formula to find it for anything beyond x squared. So the best thing I can do is factorize or outright guess. The problem with guessing is that you have infinitely many possibilities and your life is finite, right? So, is there any way to limit the number of those possibilities? And yes, there is. There absolutely is a way to limit them, and that way is called the rational roots test. So what it gives us an opportunity to get some possible zeros. Now those zeros will not necessarily be actual zeros. If you were to test this, you would still have to plug them in and see if they actually do turn this thing into a zero. However, the nice thing about those roots is that the number of possibilities is finite. The other thing that you need to keep in mind, this test will only give you the roots that are rational numbers. So if you have an equation that has some irrational roots, this test will not detect them, okay? So it only detects rational roots and it gives you a list of possibilities of what they could be. So let's go ahead and get started on this. So to find those possible roots, we need to look at two very important numbers. So the first very important number that we're going to look at is over here, and this number is called a constant. Now, why is this called a constant? Because it doesn't have an x. So if you think about it, x is a variable. So for example, if you consider the term 2x squared, this term changes depending on the value of x. When your x is 1, this term is 2. When your x is 2, this term is 8. But this term, plus 4, it never ever changes, which is why we call it constant. Another way of thinking about it, you're constant if you don't have an x, right? That's another way to remember this. Okay, so now that we've got this important number, we need to look at another very, very important number. And this one is this 3 right here. And this is called leading coefficient. So how do I find the leading coefficient? Where does it come from? The leading coefficient can always be found next to the x with the highest exponent. So my highest exponent is 5, so my leading coefficient has to be 3. So the next thing that I need to do is I need to tell you the formula for the possible roots. And this is very, very straightforward. So possible roots equals factors of the constant over the factors of the leading coefficient. All right. So, well, what are the factors, right? So let's go ahead and consider what are the possible factors that we could have in this case. So first, we're going to go ahead and look at the factors of my constant. So what are the factors of 4? If you forgot what factors are, and some of you have, because I've talked to you and I know this, think of a very simple question. Which two numbers do you multiply together to get a 4. So in this case, you have two possibilities. One is 1 and 4, right? And the other one is 2 and 2, which is just 2, right? And here's the deal. If you have a plus 1, you always have a minus 1. Because 1 times 4 is 4, and negative 1 times negative 4 is also 4. So these are absolutely plus minus. And of course, 2 is also plus minus because 2 times 2 is 4. And negative 2 times negative 2 is also 4. So I found all of my factors for my number 4. And now I am going to find the factors of my leading coefficient, which is 3. So what are the factors of 3? Which two numbers do I multiply together to get a 3? And there are only two possibilities, right? 1 and 3. Only two numbers. And of course they are plus minus. And you know, if you guys recall the numbers that have only two factors, right? Itself and number 1 are called prime. And numbers like 3, 5, 7, 11, they are all prime. Okay. So now that I've done this, I can finally find my possible roots. So I'm going to go ahead and start looking for them. So first I'm going to go with possible roots 1 and 2. So possible roots 1 and 2. So I'm just going to take this number right here, and I'm going to divide it by this plus minus 1. So what am I going to get? I'm going to have plus minus 1 divided by plus minus 1. Well, I think it's to no surprise to anyone that this is just plus minus 1. So this is my possible root number 1 and 2, right? Because it's plus minus. So here's some possible roots 3 and 4, right? So I'm still going to use this plus minus 1, but this time I'm going to divide it by my other factor of the leading coefficient, which is plus minus 3. So I'm going to have plus minus 1 divided by plus minus 3. Awesome. So once again, no surprise to anyone, this is plus minus 1/3. Very, very, very straightforward. Okay, well, I took care of this factor, right? And what I'm doing really is I'm taking every single factor of the constant and dividing it by every single number of the leading coefficient. So I will have to do this whole procedure 2 more times for my numbers plus minus 4 and plus minus 2. All right. So let's go ahead and use the 4 now. I'm going to go ahead and use this one. And this is going to be my possible roots 5 and 6. And I'm going to go ahead and grab my plus minus 4 and divide it by plus minus 1 again. So I'm going to grab plus minus 4 divided by plus minus 1. And once again, to nobody's surprise, this is just plus minus 4. And I kind of ran out of space here, so I'm going to migrate over here. So I'm going to have possible roots 7 and 8. And this time I'm going to grab this plus minus 4 and divide it by plus minus 3 this time around. So plus minus 4 divided by plus minus 3 is plus minus 4/3. Okay. Am I done yet? Nope. Nope. I still have one more number, that number 2 over there, and I have to do exactly the same thing with it. I would have to divide it by 1, and then I would have to divide it by 3. So I'm going to go ahead and put this one over here. So possible roots. And we'll have 9 and 10. And this time it's plus minus 2 divided by plus minus 1. And once again, not very surprising, plus minus 2. And the last but not least, I would have to do this with plus minus 3. I'm running out of space, so I'm going to put this right here. Possible roots, 11, 12, plus minus 2, divided by plus minus 3, is going to get you plus minus 2/3. So you can see that I found a whole bunch of roots. I found plus minus 1, I found plus minus 1/3, plus minus 4, plus minus 2, plus minus 2/3, plus minus 4/3. So all of them are possible roots. Now, are they real roots? Are they really roots? Well, we don't know until we plug them into the equation. But in general, for your quizzes and tests, you just need to find the possible roots. So that should be enough.